Hey, we're looking at properties of logarithms today. So what is the base of log x? We can rewrite this as log base 10 of x, so the base is 10. Ln of x, the base is e. Remember, we can write ln of x. Technically, we can write it as log base e of x, but nobody ever does that. Okay, so e. Change of base. We used to use this one a lot when you couldn't plug like base 4 into your calculator, but you can do that now. So anyway, change of base says we can choose any base b and then split up our logarithm into two logs. Then so we get log base b of x over log base b of a. Or say you want to have a base of e, you can use ln of x over ln of a. The base number always goes on the bottom as the input, and the input number always goes in as the top. So let's go ahead and do an example. All right, we're going to split this up. We're going to expand into two logarithms. So we get log, I'm going to choose base 10 of 25 over log base 10 of 4. Or you can write the ln of 25 over the ln of 4. And when I evaluate that, both of these is about equal to 2.31. All right, we're going to now condense. So we have the same base, which is 5. So I can actually write this as log base 2 of 16, which is, so this number here becomes your base, and this one is your number, okay? And 2 to the what gives you 16, that's 2 to the 4. All right, product property. If you have two numbers multiplied together as the input, you can split them up into two logarithms. So we're going to expand, and then we're going to condense. Okay? So expand. This could be the ln of 3 times 2, which the input is being multiplied. So this would be the ln of 3 plus the ln of 2. Think about, like, remember these are exponents. So what do you do when the bases are multiplied? You add the exponents, okay? Next, let's condense. This would be the log of 3 times of 7 times 10, which is the log base 3 of 70. Next, quotient property. First, we're going to expand and then condense. So again, if your input is divided, then you can split up. Think when you in an exponential, when you divide two numbers, what are you doing with the exponents? We're subtracting them. So we're going to have log, the base stays the same, 2 minus log of 10. Okay, condensing, our base is e, so ln 100 is the numerator and 5 is the denominator. So this is the ln of 20. All right, power property. Condense, expand. All right, so with the power property, we can, the v is being given to the x. So what we can do is, technically what we're going to do is put the v in the front. So for our first one, when the y is being cubed, we can write this as, instead of y to the third power, we can put 3 log base 4 of y. And when, oops, sorry, this is expand. Expand, condense. Okay, so this one, if we're multiplying by a constant by a logarithm, you can actually pull it to be the power. This is ln x cubed. Okay. So why does this work? Let's go ahead and check this out for a second. Okay. So we're going to have log base 4 of y cubed, which is log base 4 of y times y times y. Okay, so remember, what do you do when, what's the rule we can use when we have multiplication as the input? Well, I can write these I can use my product property and say log base 4 of y plus the log base 4 of y plus log base 4 of y, which how many, this is repeated addition, we have 3 times log base 4 of y. That's why that works. Okay. All right, a few examples. Go ahead and pause the video and try them on your own first. All right, here we go. So we're going to use the product property. I have a times x, so log base 10 of 10 plus log of x. What is log base 10 of 10? That is 1. 10 to the first power gives you 10. So 1 plus log of x. The second one, we'll use the quotient property. We have ln of 4 minus the ln of x. We can't simplify that. All right, next, we're using the power property. The power moves to the front, so this is 4 log base 8 of x. All right, getting a little trickier. First, it looks like I'm going to use the product property because I have 3 factors multiplied together. So I'm going to do log base 4 of 5 times log base 4 of x cubed, plus log base 4 of y. And then I'm going to go ahead and use the power property. So I get log base 4 of 5. And here we go using our power property. Plus 3 times log base 4 of x plus log base 4 of y. And that's it. This one, I hate roots. I'm going to change this into a fractional exponent. So I have x minus, what we have is the ln of 3 minus 5 squared all over 7. Okay. First, I'm going to use the quotient property because I need to break up this fraction. So I have the ln of 3x minus 5 squared minus the ln of 7. Now again, we can use the power property. This is 1/2. Okay, so 1/2. Okay, to move the power in front, so 1/2 ln of 3x minus 5 minus ln of 7. Can we continue on? No, because under here I have addition, or I have subtraction and multiplication. I don't have any addition rules, so we just leave it as it is. Okay, that's your answer. Last examples, here we go. So this time we're going to condense, we're going to work backwards. So first backwards property is the power property. This is log base 7 of x to the 1/3 power, or log base 7 of the cube root of x. Next, I recognize this as the product property. My factors are 4 and 2. We have the same bases, so we can condense. This is log base 10 of 4 times 2, which is log base 10 of 8. Lastly, with the subtraction, same bases. What is the base again? Oh yeah, it's e. Okay, so we're going to take the quotient property here. Use the quotient property. So I have the ln. Wow, writing is hard today. Okay, ln of 16 over x. Can I simplify that? No, we're done. Okay, last two, a little bit trickier. So first, I'm going to use the power property because I see I have some multipliers. So I'm going to go ahead and multiply those in. I get log of 10, base 10 of x to the 1/2 power, plus log base 10 of x plus 1 to the 3rd power. Using my product property now, I can combine these by multiplying the two factors together. So x to the 1/2 times x plus 1 cubed. Okay. I'm going to go ahead and rewrite this as the square root. So the square root of x times x plus 1 cubed. Can I factor in the square root? No, because you need to multiply by your exponent first for order of operations. So this is our answer. Okay. Last, power property. So the squared is going to come up. We have ln of x plus 2 squared minus the ln of x. Are the bases the same? Yes, we have base e and base e. So I can use the quotient property because we are two ln's with the same base are combined using subtraction. So we can divide the inputs, x plus 2 squared over x. And we done these for today.